And so with a quantum computer, theoretically, and these are pretty new right now, right? Amazon has one, Microsoft has one, IBM has one that you can actually program online. Google has their own. Everyone's trying to figure out how to make these qubits stable and work. But the basic idea, and I don't know what number we're up to. For a while, it was like you could only have 4 bits, qubits. Kind of like going back to the old, when we were young, the Apple II or whatever came out, and before that, there were these, small 8-bit processor-based kits that people would assemble, and they just couldn't have a lot of data because they just couldn't keep track of that many bits, and that's where quantum computers are today. But the idea is if you can have 64 qubits, you can instantaneously solve a problem that is exponential because you can explore all of those at the same time, and then when you measure the result, it's all now. Nobody knows exactly how this works, but the two explanations. Okay, coming back. Sorry, I know I'm kind of wandering a bit. Coming back to Schrodinger's cat, we say there's 2 possibilities, right? So with 64 qubits, there's 2 to the 64 possibilities. If they're all in superposition, they have all the possible values of it. And so basically, when you measure that, it brings it back. And so physicists call this the collapse of the probability wave. So there's a probability of all these possibilities, and then it comes down to 1. And that's sort of the best, one of the accepted ways that people think this whole thing works. But nobody totally knows. So another guy who was John Wheeler's grad student at Princeton came up with another idea. And we've heard about this idea from the superhero movies, right? And this is the multiverse idea, right?
Yeah.
And so basically he said that if you've got Schrodinger's cat, what happens is you're splitting the universe into 2 different universes.